Xavier cannot walk from point A to point B because there's a pond in the way. So instead he starts by walking at an angle of 30 degrees. So if you have like point A to point B, that's where he wants to go. But there's some pond in the way, so he cannot go there. So he takes off at an angle of 30 and then makes a 90. So I think I got the picture wrong. So if he goes at an angle of 30, well, maybe I don't. So let's say that is a 30 degree. And then he takes off at a 90 turn, so however far he walks, enough to get around the pond, and then he goes 90. So you got a little 90 right there. Okay, and finally he walks 40 feet to reach his destination. So after he made that 90-degree turn, he went 40 feet. Okay, so I think we got it. He can't walk from A to B because there's a pond in the way. So he turns at a 30-degree angle, starts taking off, then he turns at a 90-degree angle and walks 40 feet. So if he were able to walk straight from A to B, how far would he walk? Okay, so the 30 degrees is nice because it is a 30, 60, 90. So I'm going to flip it over my 30 and my 90, and it is going to look like this. So that's 40, that means that's 40, that's 80, that's 80, and that's 40 square roots of 3. So this is it right here, 80. Straight from A to B is going to be 80 feet. Triangle ABC is a right triangle, and C is 90. So angle C right here is a 90 degree. So use the relationships in the triangle to create two true statements. So I'm going to copy and paste this triangle. So if I got CAB, now for fun, let's make some measurements. Let's say that from A to C is 3. Let's say this is 4, this is 5. So Pythagorean triple, 3, 4, 5. We'll say that's 3, we'll say that's 4, we'll say that's 5. Now, if you drag and drop cosine of A there, so cosine of A, so we're going to do trig from A. So if we do trig from A, that's the hypotenuse, that's the opposite, and that's the adjacent. So cosine from A is the adjacent on top and the hypotenuse on bottom, so the fraction would be 3/5. Okay, now the same. This triangle right here, we're going to go from B. If we go from B, I want to make that same fraction. I want to make 3/5. Now 5 is still in the hypotenuse, but 3 this time is in the opposite spot. If we go from B, and 4 is in the adjacent. So the fraction that's going to make 3/5, 3/5 equals 3/5 is O over H. And that is the sine from B. So that goes here. So the cosine from A will give you the same thing as the sine from B. Okay, now let's look at the cosine from B. So the cosine from B. So we got B marked right here. Cosine from B is A over H, so it is 4/5. So now over here, if I'm going from A, I need to make that same fraction. I need to make 4/5. And to make 4/5, you need to put the opposite on top and the hypotenuse on bottom, and that one is sine. So the sine from A is going to give you the same thing as the cosine from B. And the cosine from C and the sine from C, these are trick questions. So we're never going to go from the 90. If you go from the 90, that's our hypotenuse. but that would also be the opposite, and then these both would be adjacent. So never go from the 90. If you're going to mark up a triangle, don't ever mark it from the 90. So that's a trick question. These two are no good. Okay, use this rectangle, and they're going to tell you the sine from this marker is 3/5. So here's this marker right here, this angle right here. So sine is opposite over hypotenuse, and this is not even a triangle. So I'm going to go straight across from here, and if I go opposite from here, that's straight across, and that is 3. And then your hypotenuse, there would be your 90 right there. So your hypotenuse would be this guy right here, 3/5. And this is the most famous Pythagorean triple triangle. This is going to be 4. This is going to be 4. That's 3, that's 3, that's 3. Now they want you to look from this marker. Look from right here, from theta. So if you're going from this marker, they want the cosine. So that's the adjacent, that's the hypotenuse, that's the opposite. So yeah, they want a over h, so 3/5. That's b. Okay, the next one. The terminal side of theta in standard position contains each point. Contains this point right here. This x and this y. So you have an angle. You're going to spin around and around and around, and wherever it stops, it goes through this dot. So this dot right here, if you're going to plot this dot, go over 8. 1, 2, 3, 4, 5, 6, 7, 8. Go down 15. So there is a dot right there. So we're going to spin, 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 and it is going to stop right here in quadrant 4. And it's going to contain that point. So it's going to land right on top of that point. Okay, so they want you to do trig, and they want you to do all 6 trigs: sine, cosine, tangent, cosecant, secant, cotangent, from the angle right here that goes through this point. So from this point, I'm going to go straight up. We're going to make a triangle. There's my 90. So from this angle, this piece is going to be the opposite. This piece is going to be the hypotenuse, and this piece is going to be the adjacent. Now I know the distance from here to here is a minus 15. Because as soon as I turned at 8, I went down 15. So I know that piece, and I know this piece is 8. So now I'm going to find the hypotenuse. So I'm going to go 8 squared plus 15 squared equals c squared. And that is going to be a 64. And a 15 times a 15, or you could even do, you could say it's negative. That's not going to matter, because if you're going to square it, it's going to turn a negative positive, or it's going to keep a positive positive. So the sign doesn't really matter. 15 squared, that's going to turn into a 225. And if I add those two together, plus 64, okay, this is 289. So your last step, undo the square. So the square root 289. Oh, okay, that's nice. It's a whole number. So that's 17. Okay, we're in business. That is 17. Now let's start doing trig. So the sine is going to be the O over H. So it's going to be negative 15 over 17. And if I flip that upside down, if I put the 17 on top of the negative 15 on bottom, that's going to be cosecant. The cosine is going to be the A on top and the H on bottom. So it's going to be 8 over 17. And if I flip that, put 17 over 8, that would be secant. And then the last one, tangent from theta, is O over A. So negative 15 over 8 8. And if I flip that, that's cotangent 8 over negative 15. So these are the 6 trig ratios from theta if it goes through this dot right here. Okay, the next one's find an angle that has a positive measure and one with a negative that are coterminal, so they start and stop at the exact same spot. So let's look at this one. Okay, the first one right here is negative, so we're gonna go counterclockwise. Okay, negative 225, so if I spin negative, it's gonna go this way, so that means that's 90, 180, 270, so 225 somewhere right in there. Okay, that angle is a negative 225. Okay, so a negative one's gonna be easy. So I'm gonna do this. I'm gonna start at the same spot, and I'm gonna spin a 360, and then I'm gonna end right there. So if I take that 225 and the negative, don't worry about the negative. The negative just means which way you're gonna spin. But if I add a full spin to it, if I add a 360, that's gonna be 585. So if I go a negative 585, that's gonna start and stop at the same spot. Okay, so now for a positive one. So positive one, all we need to do is start right here and spin this way and stop right there. So the question is, we got to figure out how much is this angle right here? How much past the 180 did we go? So we originally, this blue one, we went to 90, we went to 180, and then we stopped at the 225. So 225, if I take away that 180, that will tell me how much past the 180 I went. Okay, so this guy is a 45. So that means this one is also a 45 because they've got to make 90. So that means I went to the 90 and then another 45. So a 90 and a 45 is 135. So my negative one that's going to start and stop at the same spot is negative 585. My positive one is 135. 900 degrees. If you've got to spin 900 degrees, okay, it's positive. So that means you're going to start this way. So there's a 360. There's a 720. So if I minus 2 spins, if I take away 720, 900 minus 720 is going to be 180. Okay, so this one's not going to be too bad. This one's actually going to be pretty slick. So 180 after 2 spins. So a positive one would just be to start and stop at 180. So 180 will start and stop at the same spot, and the negative one would be to start here and end there. So negative 180 will also start and stop at the same spot. Okay, 135, we just barely did that. So we should do a different one. Let's do a different one. So 135, we just barely did. So instead of 135, let's do like let's do a 240. That's a good one. Okay, 240 degrees. So you start right here. That's your first piece. You're gonna spin and stop at 240. That's 90. That's 180. That's 270. So you're gonna stop like right there. Okay. So 240 degrees. Now same. Let's do a positive one. Positive is always, it's not bad. You're just gonna add a 360 to it. Boom. So if you start and stop at the same spot, but you just include a whole rotation, so 240 plus 360, so that's going to be 600 degrees. So that's a positive one. Now the negative one's the one that's tricky. So negative, if we start right here and end right there, how much did we go? So this is 90. So I got to figure out how much these angles are right here. So 240. If you went 240, how much past the 180 did you go? So I'm going to do 240, take away that 180, and that will tell me how much past I went. Oh, whoops, 0. So let's do this again. 240 minus 180, that's 0. Okay, 60. So you went 60 degrees right here. So this one is 60, that means this one is 30. So you need to do a 90 plus a 30. So you need to do a negative 120. So negative 120 will start and stop at the same spot. Okay, the last one is in radians. So radians, if you got a pi, radians is like part of the arc of a circle, where the radius is just 1. So it's a small circle. Radius is just 1. So if I go here, and if I go over 1, and if I spin that around, so if I spin and spin and spin, if I stop right here, that's 1, that's 1, you draw a circle, and we're talking about the part of the circle from start to finish. So 5 pi over 3. Now if you remember, if our circle's 1, if you do the whole circumference is going to be pi times the diameter, and the diameter would be all the way across that circle would be 2. So a full spin at 360 is the same as 2 pi in arc length. And arc length is the radians, so that's what we're after. So if a full spin is 2 pi, 180 is 1 pi. And this is what we're going to use because it's been reduced. So we're going to times this by 1 and we'll convert it back into degrees. So we're going to use this. This is our conversion rate. Every 1 pi is equal to 180 degrees. So if you went 5 pi's, that's like 5 180s. So we're going to do 5 times 180. So every 1 pi is equal to 180 degrees. And I am going to divide pi by pi, so it zeroes out. And now you times your tops and you times your bottoms, but first I'm going to do 180 divided by, because that's all on top and that's all on bottom. I'm going to do 180 divided by 3. 3 goes into 180 60 times, and 60 times 5, so that is the same as a 300 degree spin. So here we go, I got a piece right there, and I'm going to spin 300, which is going to end me up right here. So that's 1, that's 1. So this is what they're talking about. The distance from here to here on the circle is 5 pi over 3. Okay, so 300, I'm just going to add a spin, 360, so 660 will start and stop at the same spot, and so will this is right here, that's 60, because if I spin 300, all I need to go to finish it off is 60, so if I do a negative 60, that will also start and stop at the same spot. But now since they gave it in radians, and we've got it in degrees, we can turn it back to radians pretty slick. We'll use this same conversion rate, so 1 pi is equal to half a spin, 180. So now we're going to times this by 1 pi over 180. So now times your tops, times your bottoms. So we got 660. Now the degrees kills out, 660 pi over 180, and if you simplify that fraction, you're going to get 11 thirds pi. Okay, now negative 60, if we turn that back into radians instead of degrees, so 60 degrees, a negative 60 degrees, we're going to times it by 180 degrees on bottom and pi on top, so degrees kills degrees, times your tops times your bottoms, negative 60 pi over 180, and if you simplify that fraction, you'll get a third. So that's the same as negative 1 pi over 3. Okay, we need to find the cosecant of 135 degrees. So 135 degrees, start you right there. You're going to spin to 90, somewhere right there. That is 135 degree angle. Cosecant. The trig for cosecant, you're going to compare two of the three sides of the triangle. For cosecant, on top they want the hypotenuse, and then on the bottom they want the opposite. So it's the reciprocal of sine. Okay, 135. So we're going to make a triangle, do some trig. So we're going to drop a vertical, and that is a 90. And I need to know how much this angle is right here. So on the outside is 135, and if I go all the way to the line, that's 180. So I'm going to do 180, take away 135, and that's 45. So this angle, this is where I'm doing the trig from. I am doing the trig from the 45. So if we're going from the 45, that shape is a square. So I'm going to draw the whole square, make up your own dimensions. I'll just call it a 2 by 2 by 2 by 2. And this 2 is actually negative. This 2 is positive. This 2 is negative. This 2 is positive. Negative because on your number line 0, it's going left. Anything left is negative. This number line, there's 0. It's going up, so that's positive. Okay, the one that we spin, this hypotenuse, or the radius, is always positive. So the hypotenuse is always positive no matter what quadrant it ends up landing in. And to get this, it is going to be 2 square roots of 2. Okay, so we need, that is your hypotenuse, 2 square roots of 2, which is the r, and the o is always the y. So this is the r, 2 square roots of 2. The y is the one that goes up and down, so that is 2. And 2 divided by 2 is just 1, so square root of 2 is the answer. So on your calculator you can check, you can type it in. So before you do anything, if you type in cosecant of 135, you're going to get 1.414213. And if you type in square root of 2, you get 1.414213. So you know you got it right. The decimals match up. So it's a way to check your work, but for the test, we're not going to accept the decimal. We need the square root. We need the fraction, the exact fraction, before you rounded it to some decimal. Tangent of negative 30. So you're going to start right here. Negative means you're going to spin this way. So there is your angle. And that is 30 degrees. So we're going to do trig right there from the 30, which is nice because I don't need to find it. I don't need to minus 180 or anything. So that's the angle. Go up, vertical, and this is a 30, 60, 90, and that comes from the equilateral triangle. And I'm going to flip it over the 30 and the 90. So here is my whole shape. And I'm just going to use 2 for everything. So I'll call that a 2 by 2 by 2, which makes that 1 and makes that 1. And it makes the middle 1 times the square root of 3. So now I'm going to go through my pieces. This 1 squared of 3 is positive. This one is actually negative because it's going down. This one's positive. And the ones that we spin are always going to be positive. So tangent, the trig we need is the y over the x. So the y piece is this guy, -1, and the x piece is this one, square root of 3. So it's fraction. You've got an irrational on the bottom, so you need to rationalize it. Times it by 1. Let's times it by square root 3 over square root 3, which is just 1. So we're not going to change it. Times your bottoms. On bottom you got square root 9, which is a perfect square. On top you got negative square root 3. Square root 9 is just 3, so it's negative square root 3 over 3. So before you even go, punch in tangent of a negative 30, and that will give you negative 0.57735, blah blah blah. Now type this in, hit enter, make sure your decimals match up. If your decimals match up, then you know you did it right. Okay, next batch of problems. Sine of 4 pi over 3. So this is in radians. And we need to maybe change it to degrees, something we're more familiar with. Now here's what you got to remember. Your conversion factor is this. 1 pi radian is equal to 180 degrees. So 4 pi's would be like 4 180s divided by 3. So all we're going to do is just times it by 180 over pi, which is timesing again by 1, so we're not changing it, but pi will divide by pi, and then do 4 of the 180s divided by 3. So 4 times the 180, divide that by 3. So in degrees, that's going to be the same starting and stopping as a 240. So 240, if we got to start and stop 240 degree spin, that is somewhere right there. Okay, now 240. This angle is the one that I'm interested in, because this is the angle we're going to do the trig from. So there's your 90. So I do not care about from here to here. I don't care about that 180. So I'm going to do 240 minus 180, and that should be 60 degrees. So the 60 degrees is what I'm interested in. That right there is 60. That means this is 30, and that means it comes from another equilateral triangle. Flip it over the 30 and the 90. So your whole triangle looks like this, which is going to be a 2 by 2 by 2, which means this is 1, this is 1. They'll both be negative. And the middle is 1 square root 3, and it will be negative because it's going down. And the trig we're doing is sine. So sine is y over r, or opposite over hypotenuse. So the y piece is the one going up and down. That's negative square root 3. The r is 2, and the r, your hypotenuse, is always positive. That's the piece that spins around. That's always positive. So we are negative square root 3 over 2. So to check your work, punch in sine of 240. See what the decimal is. It's negative 0.866, blah blah. Type this in. Negative square root 3 divided by 2. And it is also negative 8 points, so it matches up, so we're good. Okay, the next one, the cosecant. So the trig for the cosecant is r over y. That's the same thing as the hypotenuse over the opposite. So it's related to sine. Okay, now same thing. They give it to us in radians, and you gotta remember this. Every pi radian is equal to 180 degrees. So if I got 3 pi's, that's like having 3 180s. So you just times it by 180. And let's divide it by pi, so our pi's will divide out. So 3 of the 180s is 540. So I got a negative 540. And on bottom I gotta divide that by 4. So if I divide that by 4, that takes us to, it's the same starting and stopping as a negative 135. So 135, it's gotta be negative. So it's gonna be this way. So there's 90, there's 135, something like right there. So negative 135. The angle we need to find is this one, because that's where we're going to do our trig from. Because if I go vertical and make a 90, this is the triangle I'm going to use. So I need to know how much this is. So I'm going to take 180 and minus 135, because all the way is 180, but I don't care about this. So do 180, take away that, and this is 45. So we are square. So your square is going to look like this. So we'll go 2 by 2 by 2 by 2, and this is going to be 2 square roots of 2. This 2 is negative, this 2 is negative. They're all negative except for this middle. So now I need the r, which is 2 square roots 2, over the y, that's the one that goes up and down, it's this one, negative 2. 2 divided by 2 is 1. So your final answer is negative square root 2. Type it on the calculator, double check, make sure your decimals match up, and you're good. Tangent of 540 degrees. Okay, 540 is more than one spin, so let's spin a 360. So if I take away a 360, it's going to leave me with the 180. Okay, now 180 lands right on a line. And if it ever lands on one of these lines, you got a couple options. It's going to be 1, it could be negative 1, could be 0, could be undefined. So the best, just punch it on your calculator. So you know if it lands on one of the 4 quadrants, it's going to be special. Just do it on your calculator. Tangent of 180, and it is 0. Okay, the last page. You got a couple circles. Find the measure of the minor arc AB. So a part of the circle. So from here to here, how much is that? So first, how much would, from A to A, what would the circumference be all the way around the perimeter of the circle? So the circumference equals pi times diameter, and this is a radius, and this is 4. So the diameter is how tall the circle is. So the diameter, so this circumference is 8 pi. So all the way around that circle is 8 pi. So 45, I'd maybe compare this. We do like 360. If I do that whole circle, and if I divide it by 45, so you can either do 45 divided by 360, or you can do 360 divided by 45, either however you want to compare them. But you will get 8 over 1, or you will get 1 over 8. So there are 8 45s in a 360. So we can divide this slice pizza into 8 equal slices. So all those slices are 45. So I'm going to take the whole circumference, and I'm going to divide it by 8. If we divide it by 8, that means each of these is just 1 pi, 1 pi, 1 pi, 1 pi, 1 pi. So you're good. Okay, next one. Now this is the unit circle. You got a tiny little circle. So the radius is just 1. So let's compare the 120 to the whole circle. So 360, or you can do the other way, 360 divided by 120. 120 over 360, that is a third. Or there are 3 120s in 360. Okay, the whole circumference, the circumference is going to be 2 pi. So 120 is to 360, so 1/3. What is 1/3 of 2 pi? And it's a fraction. Just divided by 3. So 2 pi divided by 3 doesn't work out very good, so it's going to be, this is going to be 2/3 of a pi. Okay, last one. If you have this, if you know that 2 pi is 360 and 1 pi radians is 180, how many degrees is just 1 radian? So 1 radian, not 1 pi radian. So pi is really 1 times 3.14. So this is like 3.14 radians equals 180 degrees. So if we don't do it in terms of pi, if we just do it in terms of radians, it's really like 3.14 radians. So if I divide this side by 3.14, that will give me exactly 1 radian. But I gotta divide this side by 3.14, so if we do 180 divided by 3.14, we will get, it is 57.33 degrees.